Hey there, and welcome back to the channel. I'm Brian, and in today's video we've got board 005 on the bench. Now this board may look a little different. It's still got the heat sinks on. See that? Yeah, these are the factory heat sinks. The plan for this board, I'm going to leave the heat sinks on and actually try to get it working in the miner. This is very unusual for me. Normally the first thing I do is strip all the heat sinks and then start working on it. So I'm going to learn a new technique. Okay, so I've got my old man glasses on so I can see what I'm doing. I haven't worked on this board previously. This is the first time this board's been on the bench. What I do notice, let me see if I can zoom in on it. What I do notice is it looks like this capacitor right there has been removed, or it just came flying off. So I'll end up putting a new capacitor on there, that's for sure. The other thing I did is I just started jumping because it shows 0 ASICs. So let's do that. Let's start with capacitor is not going to be a problem for testing. So let's do a quick test so we all are on the same page. So let's see what we get. Pretty sure it's going to give me 0 ASICs. Yep, gives me a 0 ASICs. If I come in here and get some light on this, let's go to the microscope view real quick. All right, so that's between chips 4 and 5. I can grab 1.8 volts from chip 1, and I can't even get a jump there. Okay, that's a bummer. Let's go the next one over, so this should be 3. There we go. Maybe? Yes, I got 3. Okay, I'm having a bit of trouble getting my 1.8 volt. There we go, I got 3. Okay, I can get 4. Okay, I gotta go over to the next domain. See if I can get 5. Oh, looky there. I did get chip 5. I got 6. That's good. I got 7. Got 8. Okay, it looks like I found the problem. Okay, so maybe whoever sold me this just was helping me out. So I did the jumping. Sorry for being so difficult to see, but man, it's kind of tough to jump whenever you've got all the heat sinks in there. Definitely easier when you can pull it off. But this one right here is it, right? So when I got this board, someone took off these 4 heat sinks, and this one I can jump to those probes, but when I get to this jump point I get nothing. So I got 8 chips, but I don't have 9. So I'm gonna go ahead and swap that chip out right there, and let's see if that doesn't help this board get back to life. All right, what do you think? Comment down below if you think this chip has been pulled before. Just looking at the microscope zoomed in, I think it has. And I don't see anything terrible. There was a generous amount of flux being used. So. All right, that took a little bit longer than I thought. So this, that chip was a little bit harder to solder too. Turns out the reason why it was harder to solder is because the person who worked on this board actually took the back heat sinks off. So we're gonna have to put those back on in a bit, but let me show you this under the microscope. Some of you probably already know this, but I didn't. And so this answers a question that I had on another board. So this right here is a PLL. It takes, I believe, if I put a probe right there, I'm gonna get 1.8 volts, and then on this side I'm gonna get 0.8 volts. So why is that relevant? Well, because this actually takes the 1.8 volt, I believe, and drops it back down to 0.8 volts for the top two chips in a domain. Let's check my theory though real quick. Let me hook it all back up to the tester. So I should be able to put a probe right there. I think that's pin 1. I get 0.8. Now if I come over here, so that's 1.8 right on that side, and then this is pin 6. So this is pin 1. Okay, yep, cool. So there we go. 1.8 on the input side gets you your 0.8 on the output side. And this is how the top two chips in a domain are powered. Let me show you more about what I'm talking about. So this is my parts board, and as you can see, it's been stripped. However, let's look at something. If I go under the microscope again, I'm gonna start with chip 6, right? You can see why it's a parts board. It got burned. There we go. All right, so that's chip 6, and in case you don't know, pin 15 here and pin 18 here, that's where the 0.8 volt gets carried through the chip. So it comes up here, goes along, comes by this capacitor, and then it goes here. 0.8 goes through the chip. All right, comes up to this capacitor, goes to this pin right here. Okay, pin 18, comes through the chip. And then look at this right here. This like missing resistor. So in domain 2 on an S17 plus, it's R053. If you look at your boards, you'll notice that none of the boards have a resistor here. And if you try testing it with an ohm meter, there'll be a break there. It just won't go through. Well, the reason why it's not going through is because of that PLL chip on the back side. So what actually happens is that we get fed our 0.8 for chip 9 and 10. We get our 0.8 voltage. We get it fed from that PLL on the back side. Something to put away in our heads for later, just in case we ever find ourselves not getting that 0.8 volt. That may be why. So if you check and you lose the 0.8 volt, it could be that chip has failed on the back side. Haven't seen it yet, but at least now I know a little bit more about the power structure of these chips. Okay, let's get back to diagnosing. All right, I'm all hooked up. Hit the go button. Woohoo! 9 chips. All right, so replacing that chip was a good one. Now we got this chip to contend with. I'm going to do the same thing, right? I'm just going to replace this chip. And see, I think the tech who worked on this actually helped me out. So I'm going to go ahead and replace chip 10. And once I get chip 10 replaced, then I'll probably put those heat sinks back on, because I think we're about done with these two domains. I replaced chip 10, and I'm just going to go ahead and put these back heat sinks on, because I'll tell you, it's actually harder for me soldering and desoldering chips when those heat sinks are off. I think it's because you got to focus more of the heat into the board, and the heat sinks on the back just help that. But then again, I put chips on and I take chips off from the back side. So it's really, really simple to put these heat sinks back on, in my opinion. I just add a little bit of flux like I just did. And then I heat up and I just pre-tin it. Honestly, I don't need to add very much solder because it's already got solder on it. So I'm just going to add a little bit of solder to both sides of this. There you go. Oops, forgot to put flux on that one. These pads have already been cleaned up, but obviously you want to make sure you clean up your pads. I always start from the inside when I'm having to put these back on, and I work my way back out. Okay. I'm going to run this a little bit hotter. All right, I wish I could like really figure out a way to do this camera view where you could see what I'm looking at. Let me show it under the microscope. Maybe we can get it there. Okay, so besides watching for the heatsink to actually settle down, probably saw that in the video, I'm looking for this right here to get flat. All right, so once I see that get flat, usually you see it bubble out from underneath. And when I see that joint right there get nice and flat, then I know I've gotten the heatsink to mount properly. I take the heat off, let it sit for a bit, and it's good to go. All right, let's see what we've got now that all the chip work's done there around 10. Boom. Oh, man. All right, let's check our temp sensors. That looks pretty good for a first time in the miner. I think it's going to be good. All right, let me go find my chip quick, my low temperature chip quick, and we'll put a little bit of solder on each of these chips, and we'll get this thing in the miner today. All right, so I was so excited about 65 chips that I got a little ahead of myself. We need to replace this capacitor right here. So I took the shield off. Yeah, I took the shield off, and Great Voyage Inc. I don't know if that's a mining company or a repair company, but that's where this board lived for a while. I need to clean this pad up and put a capacitor on. And while I'm at it, let me show you this chip under a little microscope. This chip looks like it's been hit by a meteorite. Big old crevice taken out of it. So why not? Let me go ahead and take it out. You can tell that this chip has been run really hot. I'll clean the pad up, take a chip off, and put a fresh chip on there. Okay, I always like to heat these from the bottom because you don't want to expose the electrolytic capacitor to hot air, because that tends to cause the capacitor to explode. Since I did replace another chip, let's go ahead and make sure that it still works. See? It was worthwhile checking. think I broke it. All right, well, let's find out what I did. Should be pretty easy since I only did two things, right? I replaced this capacitor and I replaced that chip. So let's come over here to number 10. Okay. I feel pretty confident. Let me see here. I'm going to reach over here. Get a little bit more light. Can't see. There we go. It's 45. 55. Okay. So odds are really good that I messed up that chip. So let me just reflow that chip. Putting it back on the tester, running it, still got that problem there. If I check my voltage here, what I'm going to find on my RO is it's good on this side, not good on that side. So, okay, bad chip. All right, new chip is put on and we got 65 chips. Yeah, buddy. That's what it's supposed to do. So I'll throw away that other chip right here. Oh, good, good, good. I got good temperature sensors all the way around. Now, while I was waiting for things to cool, I went to my scrap box and I found 4 heat sinks. Right, so the right ones, and I went ahead and tinned them up with some low temp solder, some 138-degree solder. What am I using? Let's see, Chip Quick NC191 LTA. I got a 15-gram tube. I could have got the 10-gram tube, probably would have been fine. I don't plan to do this all the time, but it was like $2 more, so I got the 15-gram tube. Just a dab of flux on each of them. I'll start up here. I've never done this before. I've taken them off, never put them on. So I hope you find this to be entertaining. Alright, since I've never done that before, let's go back to the tester. Just make sure that I didn't completely ruin the board, right? I didn't mess it up. Oh good, I didn't ruin it. Alright, good, good, good. Let me go ahead and get the other zone. Same technique, right? I'm just gonna place it on there, heat it up, let it sit. Okay, let's find out if it still works. Woohoo! 65 chips, heat sinks are on. Let's check the thermals. All right, look at that. Good temperature readings all the way around. Voltage looks fine. So I'm gonna go ahead and go get this in a miner. Okay, look at that. We got failed. Wait a minute, hold on. That's chain 0. Well, okay, I've got another problem. Good news is chain 0 or chain 1 here. This is board 006. This is the board we're working on today. I'm not sure why we've got a failed pick. We'll deal with that in a little bit. That'll be for the next video. But for now, let's see how we're doing. All right, it looks like this the pick issue is going to cause me a little bit of trouble on chain 1. That's board 002. It's been working. Not for sure what's going on with that, but fixing a pick is a real quick fix for me. I've got a couple of extra picks that I bought. Got them off of Thanos Mining if you need a source for pick chips. Just saying. All right, let me go pull that pick chip real quick. All right, so this is board 002. This is not the board we were just working on, but I wanted to put it in, and sure enough, see, it shows that it registered the board. Let's find out. Let's find out if it'll read it. Okay, 65 chips. I'll tell you what I'm going to do. In this scenario, I'm just going to go back. Alright, I'm just going to read the EEPROM real quick. Alright, yeah, see, I can do it here. Let's get out of this. Let's go over here. I'll do a read EEPROM. Yep, it read it just fine. I'm going to go ahead and put a different... there we go. I'll do that one and write it, and it's successful. So I'm going to slap this back in the miner real quick. I think we're probably okay. All right, look at that. It looks like it was just a loose connector. So lesson learned. When you're messing around with the boards, make sure you just touch those connectors. Make sure they're nice and secure in there. Apparently I knocked it loose. All right, let's see how it does. I'm going to let it settle on down. I think this one settles at 18.4, 18.6. So let it get there, and I'll show you what's happening. All right, looks like we got down to 18.4 volts. And if I flip over to the stats here, I see that it looks like we've got all 3 boards are running. The middle board is the board we just worked on, right? That's 006. And it's the wimpiest board of all, but I think that's pretty easy to see since we have a domain that's not fully rocking and rolling. But hey, I'll take it. So let's look over there and see what the domains look like. Yeah, you can see right here we've got the 13th domain on board 006 it's not running all the way. So like chip 63 is the chip I've replaced, and it's red. The whole domain's red, so odds are I just need to reflow that domain. But to reflow the domain means I need to take the heat sinks off. I'm not going to do that right now because I'm just going to let the board run. But yeah, this is really good. I'm quite happy with this for now. So board 006 went from the bench never being in a miner, heat sinks missing, 0 ASICs, to fully hashing, and I left the old heat sinks on. And so I'm kind of excited because this is the first time I did that. I don't plan to do that all the time. I like the new heat sinks. I do think that they're easier to work on the board with. So I'll be upgrading this board in the future. But I wanted to get one more video in because this will be the last video I probably make for 2 or 3 weeks, because I'm going to an ASIC repair school for the next 2 weeks, and then I'm taking a vacation after that. So I'm looking forward to what all I learn. And if you happen to be in the Austin, Texas area the last week of April or the first week of May, hit me up on Discord or reach out to me via the About. I'd love to meet up with you in the evenings. I'm going to be in class 8 a.m. to 5 p.m. learning some new skills that I can bring back to the channel and share with all of you. So thanks so much for watching. If you saw something I did and you think you could do better, or you've got a better way to do it, please comment down below. If you liked the video, give it a like. If you haven't already, subscribe. It really helps the YouTube algorithm out. Thanks so much for watching, and I'll see you real soon.